And that's the cool thing about this facility. You have here, you know, this artisan handcrafted work of the highest quality, but then also automated high volume production.
Hello everyone and welcome to our yearly recurring video where I have the opportunity to visit one and only Mate Rimac and his little empire that he's built by now. Every year we've been visiting and showing you the latest updates from the Jankomir Tech Center and now the latest Rimac campus. So you're going to show us around and see what we have here. We're actually going to go back first to Jankomir because the last time you saw it, and in case you missed this video, check it out in the video description that I will definitely forget to include. It has changed ever since, so we're going to check out what is happening there and later take you to campus, maybe go for a ride in the Nevera. But since we are shooting this episode during Christmas season, I need to give you something. So, Merry Christmas, Mate. So first of all,
ugly sweaters, yes.
Yeah, not only that, of course our Nevera sweater, but I made you something special and I would like you to open this.
Okay.
It's a new design that we have made.
Okay.
Let's look at the label first.
Supercars prototype 1 for Mate Rimac. Okay, nice.
And then look at the back.
Oh wow. Cool, man. Where's the E30?
Asking the right questions. That's why it's a prototype. The final production will be unveiled later.
Oh, very cool.
You also have a hoodie. And if you guys want to get it, check out petrolheart.com. Use code Misha10 for 10% off. And you can be as stylish as Mate Rimac. And maybe as successful as he is one day. But that doesn't come as a guarantee with the merch. Anyway.
Yeah, something for you. A little bit of Rimac swag, so.
Nice. Exchange.
Yeah, we exchange, yeah, exactly.
Fantastic.
Exactly.
All right. You guys, watch the Jankomir and we go check out the campus to show to you in a bit. So, where are we now?
As you know, we were a company making cool technology and very advanced high-performance powertrains and batteries and so on. But to make a jump from that to high-volume production is a big jump that very, very few companies actually did in the last decades. Usually, companies who make that are decades old, maybe 100 years old. We are not that old, right?
Yeah.
And to make the jump, it's very complicated to get, you know, tens of thousands of parts, the right flow, at the right moment, with the right processes and so on. So I'm really proud that we did that now. So this line produced just in this year 25,000 batteries for a sports car. It's a small battery, a hybrid battery for a quite interesting sports car that's on the market already.
992.
I can't say anything. So
just open the front and you will see a sticker probably.
Yeah. So we do that for many car companies now, but the thing is when you develop a product like that, both the car but also the parts, it takes like 5-6 years to develop it. So we have started this project like 6 years ago and now the production line is running and everything works really well, which is something that we haven't expected, doing it for the first time, but also our customer thought like, oh, like these guys will cause us lots of headache and trouble. But now that we have this running, this really helped us to get so many other projects for so many other OEMs. I mean, the public one is BMW. We have a huge project with them, a lot bigger than this. But we also have some others that are not public yet. So this was a great showcase for us also to show to other car companies when they come to us, like, give them peace of mind, these guys can do it.
Yeah, awesome, awesome.
We can't show too much, but this is a pretty interesting part of the process. You see how careful the robot is by manipulating the battery, because here it's already a live 400 volt system that can, if something goes wrong, you know,
it will go wrong.
It goes wrong big time. So the robot is really careful moving the thing around. But this is an interesting part of the process where resin is inserted there. You see there's lots of these blue splatter of the resin.
Yeah.
and you have the cooling system already in place, and the cells are already welded, and then the robot picks up the cells, and 100 welded cells need to get into the cooling system with less than a millimeter between each cell and the cooling system, and it can't touch anywhere. So you have like 200 touch points where it could go wrong.
Wow.
So it has to be super precise and very careful to put it in. As you put the cells in, the resin rises inside of the container, and just when the cell is inserted, the resin needs to be perfectly aligned with the top, and then the resin keeps the cell in place in case of vibration or a crash, but also enables transfer of heat from the cell to the cooling system. And then the robot puts it into this rotating storage compartment where the resin then cures, turns it around, does the same thing on the other side after a few hours, and the same thing, and then you have the core of the battery done. Then it goes for further production, adding electronics and other stuff. So once this is done, the pack gets closed there, and then we have end of line, so every pack gets tested, like you pressurize it with air to see if it leaks, but then you also pressurize the cooling system with water to see if that leaks. Then you do charge and discharge tests to see the performance of the battery. You flash the software and you check the communication of all the systems. If everything's all right, it's done and goes to the customer. And so far, like, that's also a big thing for us as a small company, less than 1% scrap and 0 failures in the field. So we had 0 issues with cars in the field already for 1.5, 2 years.
Yeah.
So maybe nothing special for a big company, but for us, you know, it's something we are very proud of, because we didn't know how to do this 5 years ago, and now we are doing some of the most complicated cars, you know. So yeah.
But it's been always like that at Rimac.
Yeah, I just showed we just had our big all hands, you know, where the whole company comes together. And I dug out a slide from 2019, which I had on our all hands in 2019, where I said, this is the goal for 2019. And by the way, just for everyone to know, this is 2025.
Yeah.
Like my vision for 25. And the goal for 2019 was to make 3 cars, concept ones, to have 30 million revenue, and I don't know, like 50 batteries, whatever. Yeah. And the goal for 2025 was like 500 plus million revenue, to make 100 plus cars and like 50,000 batteries or more. And now in 2025 we have like combined Bugatti, Rimac, Rimac technology have like 800 million revenue, so we overshoot it. We produced 125 cars, and we delivered not 50,000 batteries, but 25,000. So, but when you aim from such a low base to such a high, big target, which at that time seemed completely insane, it's pretty remarkable that we have pretty nailed it, you know?
Yeah.
So sometimes people ask me like, did you plan for things to go this big? And when I look at my first business plans from like 2011, 12, when I just started, we pretty much nailed it. At that time I thought we would produce a lot more cars and a few batteries on the side. Now it's the other way around. We produce few cars, many batteries, and powertrains and so on. But the ambitions were always huge. So I always was shooting for the stars, you know?
Yeah, nice.
Yeah.
Very cool.
So here I can show what we are doing, because this is the battery for the Bugatti Tourbillon.
Oh.
Yeah. So this is a module.
Okay.
And it's very different from the battery that you have seen before. It's similar cell with the 21700 cell format, different chemistry, but that battery over there that we produce in high volume is cooled with refrigerant coolant, or basically with water glycol.
Yeah.
So the cells cannot touch the coolant, because water glycol is conducting electricity. Here, this is a very, very high performance battery, because the Tourbillon, as you know, is a hybrid. So you charge, discharge the battery all the time. Unlike an electric car, basically you have just the battery as a power source. You deplete the battery, you need to go to charge. This one gets charged and discharged all the time. So cooling is very important. So how we cool the cell is with direct cooling. But when you directly cool the cell, it has to be a thermally conductive coolant, but electrically non-conductive coolant. And that's oil, or other synthetic materials like polymer-based coolants, but in this case it's oil. So the cell is in this plastic container and it's being held in the middle.
Okay.
So you have space on the top and the bottom
Yeah.
where the cell is welded, and that's also where most of the heat is generated. And then you have oil flowing through this gap on the top and the bottom, directly cooling the top and the bottom of the cell. And then you have these, as you see, this copper is welded to the cell. So that's also very important. You see these circles, that's the laser welding. And that's very difficult to get right because you have 0.3 millimeter thickness of copper welding to 0.1 millimeter of stainless steel, and you can't penetrate the steel, otherwise the cell is ruined, the module is ruined. Then another very difficult thing is sealing. So we have like 300 different points of failure where the sealing, where it can leak. So leakage is a huge issue with such a concept because everything is flooded.
Of course.
So everything you see here, you see these holes, this all needs to get laser welded. The plastic needs to get laser welded.
Okay.
So you put a lid on here, and that's happening actually here.
All right.
And the interesting thing is you have this lid which is transparent because the laser needs to shine through this piece onto the black piece and simultaneously melt this little lip. So it simultaneously drops here, but not just this lid, but also these pillars. You see these pillars in the middle? Because it's all under pressure and it's a big surface. So in a big surface area, even small pressures create a lot of tension. So if you didn't have these pillars, it would fall apart. So you have the pillar going from one side to the other, so where the pillar is, there is no cell. So these pillars then distribute the force between the two sides, eliminating each other. And then you have all the battery management systems, so the sensor, the temperature sensors, the voltage pickups, everything is inside. This also needs to get sealed, so you have like per module, you have like, I don't know, 5-6 meters of welds just for the plastic, then more meters of welds for the cells, and you have 6 of these modules in every tourbillon. So it's a super complicated battery to make, very, very complex, and the leakage is like the biggest issue. So we worked like 3 years on fixing leaks. You fix one, it leaks somewhere else. And we fix one by the other, and it's just such a tedious, detailed process. But that's what it takes if you want to push really, you know, the maximum of technology. And you know, only because of the, you know, some people will say, okay, I don't care about the battery, that's boring, like just show me the engine. But without this battery, there would be no V16.
Of course.
Because in my head, when I decided to do the V16, was like, okay, so we remove the turbos, I mean, compared to the Chiron, right?
So you increase the emissions?
Yes, not necessarily, but it's more, you lose torque, you lose power.
Yes.
So, in my opinion, from an enthusiast perspective, a hybrid is already a compromise. And a turbo is a compromise. So, to not have two compromises, you remove one compromise. So, in my opinion, like having both a turbo and a hybrid is not the right thing for an enthusiast car.
Yeah.
Turbos are great, but like in the Chiron, when you push the throttle 2 seconds, without exaggerating it, nothing happens. You know, it takes time to spool up. And the turbos are very loud. They muffle the engine sound and so on. So in my head it was, okay, we know how to make a very high performance electric powertrain that will add the power, but also the reaction time to be much better than in the Chiron. And then you can make a very old school, loud, naturally aspirated, high revving combustion engine. So some people might say, I don't care about the battery, but that's the enabler to have a cool engine.
Epic. Well, seeing how much work goes into it just in production alone, I would say the price of the car is justified based from that technology standpoint alone.
Believe me, we raised the bar with everything with this car. You'll see there's so many things where we said, okay, it's not enough to just, you know, go one step up.
Yeah.
But we do whatever, you know, that's my thing. I think like a sensible business person would say, okay, let's take the Chiron, let's take the Nevera, put it together.
Yes.
You know, not do everything from scratch. You already have this and call it a day.
Yeah.
It's, you know.
But then that's how you do things.
I don't do things this way. I always start from scratch because I don't want to make any compromise, or, you know, I just can't, when I know it can be better, I can't say like, okay, you know, I just do it halfway. Yeah, so this is the assembly then of the pack. So imagine this, imagine you're standing next to a Chiron, which is a pretty small car. People would be surprised, it's a pretty small car.
It is.
And then you say, We have a 25 centimeter longer engine. This battery pack, 3 electric motors, more performance and everything, where do you put it in the car? And without making the car any bigger. So when I decided to do the V16, I asked the engineers and the designers actually, so is it good for you if the car is a little bit longer, like especially in wheelbase? Like it might be good, I don't know. And they're like, no, just don't do that please. Like make sure the car doesn't get any longer. So we wanted to keep the cabin the same comfort, like the Chiron is very comfortable. We wanted to have a larger storage space, larger trunk, and then longer engine, this huge battery pack, 3 electric motors without making the car any longer. And we just made it 39 millimeters longer wheelbase.
Okay.
Which is pretty insane. If you think about like, this is a big thing, you know, it's a 180 kilos battery pack. And on top of that, the Tourbillon is basically the only hybrid car that I know of that's lighter than its combustion engine predecessor.
Wow.
And this thing is 180 kilos, so just the battery. Then 3 electric motors, 3 gearboxes, 3 inverters, high voltage components, and we still managed to get it below the weight of the Chiron.
Yeah, but you took away, of course, the turbos and all the...
Just the engine is 200 kilos lighter.
Yes.
And then the cooling systems and so on.
And on the front, you do not have like the extra drivetrain from the gearbox and the differential. So
exactly.
You use, it's actually better.
Yeah, you get a better product by smart architecture.
Yeah.
Without taking anything away, actually adding, I would say, more performance, more excitement.
So I guess this sits in a transmission tunnel?
Yeah, so the Chiron used to have the gearbox in front of the engine, and that was a very big gearbox. So it meant the passengers were sitting far apart, which was great for comfort, but unnecessarily far. But that also creates a big cabin, and that creates a lot of frontal area.
More drag.
Exactly. So people always think about CD, but that's the drag coefficient. The real drag of the car is the drag coefficient times the frontal area of the car.
Yeah.
So you want to reduce frontal area. So what we did, gearbox is now behind the engine, in the back of the car. The battery is now, so this is where the driver would sit, the passenger would sit here.
Going for a lap?
Yeah. And so the tunnel is much narrower. Still, the passengers are far enough to not, to be comfortable, to not rub their...
Not be awkward,
yeah.
Be comfortable enough to hand over the snacks.
Exactly, exactly. And the cabin could shrink. That gives great advantages in aerodynamics, but also in design, because you have shoulders. So when the greenhouse or the glasses move together, the car gets, muscles. So it looks a lot better as well. So these are the 6 modules. This is not a finished battery pack, it's just being made now. So you don't see any cooling distribution. That's because the structural floor of the battery has integrated cooling channels in the carbon fiber, in the structure of the carbon. So the modules you just position them there and they connect to the plate, and that's it. So 6 of these modules, 25 kilowatt hours, which is pretty big for such a car. So this enables like 50, 60, 70 kilometers of all electric drive, which isn't really that important for our customers. They will always drive with a combustion engine on, but in some areas we wanted to future-proof the car. We think in some cities you might not be able to come in.
Yes, without being able to drive fully electric.
Exactly.
Yeah.
So, or you want to, sneak out of your neighborhood.
Out. Yeah, I was about to say. Because your kid is asleep, not because you want to.
Yeah, exactly.
Something else.
Yeah. So that's the battery pack. I'm quite proud of that. And you see, like all of these white or transparent plastic pieces were laser welded to the black one, and you see all of these pillars that connect the 2 sides. So this is a very engineered product.
So there's like no glue or adhesive whatsoever.
No glue.
It's
all laser welded.
Wow.
So laser welding plastic, laser welding the copper to the steel. Lots of electronics. So we do all the electronics, the hardware, the software, the battery management for that on our own. So, and then when you see what we do for other car companies, it's completely different again, because this is like way too expensive to do it for anything else. Yeah.
And also very low volume.
Yeah, so usually what you will see here, we have 1 production line for prototypes. So in the auto industry, you have something which you call samples. So you have A sample, B sample, C sample, D sample. So an A sample is just any prototype. You just make it somehow, just that it's roughly representative of what the product is. A B sample needs to have the real performance, but it doesn't matter how you make it.
Yeah.
C sample has to have the rear performance and the real shape and everything, and also has to be made on the real line, but it doesn't have to be the real production tooling. D sample, everything is as in series production. Usually what you see in our company here, we have a special production line for B samples, and then C sample is like series production, which is completely different, large scale. Here we produce the B sample in the same way like we will produce the series production, because it's just a small volume, it's 120 cars per year. So still, you know, a battery pack every couple of days, but we do that in other lines in every couple of minutes.
Yes,
you know?
yeah.
So it's totally different. And maybe something interesting here, so the battery doesn't have a cover. It's fully integrated with the monocoque, so the car, the structure of the car is the cover of the battery. So when we test the battery for thermal runaway, for example, when you need to explode a lot of batteries and burn them and stuff, we don't want to burn the whole car, so we have this like piece of the car. So it's basically the same like in the car, it's just like cut out. That's also how we transport the battery. But that's how, one of the reasons why we didn't make the car bigger, we really integrated things. So one of the things was the battery doesn't have a cover, but the car is the cover. So that's how you think architecturally, like how do we squeeze every millimeter out everywhere?
But it's somewhat similar that you've done to the Nevera, where the battery is like actually part of the structural...
It is, but the Nevera has a structural cover and then the monocoque on top. So you have like two covers basically. Here we managed to reduce it, gave also lots of other headaches, but we managed to do it. So it's not a huge thing, but it saved for sure like maybe 10 kilos and, you know, a few millimeters, you know, and
that can be a lot.
That adds up.
Of course, of course.
This is a Nevera battery pack, Nevera R, so totally different compared to the Tourbillon. I mean, it's on one side and it's an EV, so 120 kilowatt hours of battery, but also for us kind of ancient, because we designed it like 5-6 years ago, and that's for us like, you know, the Rimac's dog years, so that's like, you know...
25 years ago.
Yeah, exactly. So it's not flooded, it's cooled with a liquid, but different from the high volume battery you saw. Here we cool top and bottom, so you have a top and bottom plate to cool the top and the bottom, because that's where the heat is generated.
So the assembly, what we're seeing here is pretty much identical to what we saw there.
Yeah. It's
so
like
that's why all
manual.
the extra, we do not expect all this extra assembly on top of the other battery. This is just like really the evolution of technology, how much extra stuff you have here compared to how much you do not have there.
It's a completely different concept, but still this is like the most powerful battery in a production car right now. It's 1.5 megawatts, so that's like over 2,000 horsepower. And usually people would think that on something like a Nürburgring lap, the battery would be the thermal limit of a car. And in our case, with the Nürburgring, or even with the 430 kilometer per hour world record run, the battery is not really getting hot. So we start with maybe 25 degrees, and at the end of the lap, I now forgot, but I guess you were maybe 35, 40. The battery can go like to 60, 65 maybe if you push it. So we made a big leap with this battery pack. We actually use the same cells here and in the Tourbillon. So this actually has more potential. But you always have a limitation in a car. So to simplify it, with an electric car, you have 3 limiting factors: the battery, the inverter, and the motor. Then gearbox and so on, the drive shafts,
tires on the track most of the time.
But let's say from a powertrain perspective, these 3 elements. And the Nevera initially, in a normal Nevera, the battery was the limiting factor, the inverter could do more, and the motor could do more. And then with the Nevera R, we have this new battery with a new chemistry. So now the battery can do a lot more, but the inverter we managed to get a little bit up. So now that's the limiting factor. The motor could maybe do a little bit more, but that's now the balance. So we changed the balance of performance, and now the battery is like oversized, but that's good because it doesn't thermally limit you ever in the car.
So the BFI gonna be a RBFI,
yeah,
really big inverter.
Yes.
Yeah.
Place changed a bit, huh?
Yeah, every year it's completely different.
Yeah, and you know, I always thought when we finish campus that we will move everything there and we don't need this space. Well, this is completely full, campus is completely full, and we already plan building more.
Yeah. And Svetaneda is still being used by Vern, right? Or
yeah, by Vern, but also there's some testing there. So everything is used, everything.
That's what I learned as well, there is never enough space.
Never enough space.
That's why real estate business is so good.
Yeah.
Because everyone wants space.
Exactly. This is our B sample line. So we have a whole production line just to produce B samples for other car companies, so that we don't have to produce a line for every project. So it's like a flexible production system.
But I think eventually that's also the way you should be doing things, because you deliver a prototype to a client which is already perfect. You're not going to say, like, don't look at this, don't touch this. It's already final product, and then you can take this B sample to upscale it completely without thinking like, we had their issue. You just make it bigger, and that makes your life easier.
It's a different world when you work for the large car companies.
Of course.
Believe me, they make damn sure that what we deliver is, on the highest level. And you need to understand, like, we are competing against, the world, including the Chinese manufacturers that make batteries and so on. And we need to be technically better and commercially better. Otherwise, the car companies won't choose us, they will choose someone else. And that's not easy, especially competing with the Chinese. They are really, really good at doing this stuff. We need to have our edge. So the products need to be reliable and like robust and everything, but also cost. Like, yes, for Tourbillon, it may be not that important, but the other stuff that we do is for more normal cars. There's more everyday cars coming with our batteries and our powertrains.
Every 100 euros matter. Every euro matters.
Yes, every euro matters. Yeah. Especially with also the OEMs now getting more and more pressure from Chinese competitors. They also can't afford to pay outrageous sums for their European suppliers. They will choose Chinese suppliers if they are better. It's very simple. Yeah. So we need to be better technically and commercially.
So this is where the Nevera production line used to be, right? And now it's not anymore.
Not anymore. Until 2 weeks ago, there was like a production of batteries here. We are now removing that because here comes a mass production line for the powertrains.
Okay.
So this is our B sample powertrain production. So here we produce in low volume the Tourbillon powertrain. So this is the front axle.
Okay.
But also this is a high volume e-axle that we do for another manufacturer that we will produce in very high volume. So here will be a mass production line that will produce that automated. But of course the Tourbillon is very low volume, so it's not needed. And you can see the progress from the Nevera. So here we have the Nevera rear powertrain, just without the inverter. It's 2 motors and 2 gearboxes. And you can see how big it is compared to the Tourbillon. And this is the whole system. So 2 motors, 2 gearboxes, 2 inverters, and it's 80 kilos, and it can provide 660 kilowatts of power.
Let me just double check this, because I remember when I was still in the company 6 years ago, and we were making videos explaining this. This appeared to me so small.
Yeah.
This, like, it looked like this to me when I think about it.
Yeah.
But now when you compare it, it's massive.
Yeah. Now, one of the things, for example, you can just see from the outside, like it's not integrated. Like the motor is separate from the gearbox. It's like separate housings. You see, you have like one plate here, you have another plate here. On the Tourbillon, it's all much more integrated. It's higher speed, like this is 24,000 RPM.
Wow.
Without a carbon fiber sleeve around it for cost. And the Nevera was 17,000 RPM with a carbon fiber sleeve around the rotor. So we managed to reduce the weight, increase power density, increase efficiency a lot. This is much more efficient. And cost is like less than half. So you would think like, why cost? Like, why does it matter? Well, Bugatti needs to be profitable as well. Like, we can't, Bugatti was this amazing project of Ferdinand Piëch in the last 20 years. And Volkswagen, with its big pockets, of course, could afford to finance it, even if it wasn't making money. Well, we can't. We want to have Bugatti Rimac as a very profitable company. So therefore, we want to, of course, raise the performance and quality and everything to the highest possible level. But at the same time, we want to be sustainable. So cost is a factor. So here we make all of these things. And then you see that we basically apply the same principles to a totally different product. So while this is a front axle of a hypercar that goes 500 kilometers per hour, this is a rear axle of a big family SUV. So the least complicated part is the gearbox. The medium is the motor, the most is the inverter and the software in it. So when developing a new e-axle, we try to keep the same inverter, but then you scale the motor, you make it bigger diameter and so on, depending on what you need. So I think that this one has an output torque of, I believe, 13,000 Newton meters, something like that. Well, this one is just 3,500 Newton meters.
Just.
Yeah. Why? Because it's front wheels, so when you accelerate with the Tourbillon, for example, the center of gravity transfers to the back, So your wheels lift, you can feel it in every car. The wheels lift in the front, so you have less weight on the front wheels, so you don't have that much grip to transfer anyways. It's interesting in Nevera where you can play around, you can adjust
the torque factor.
Yeah, you can adjust with the knob just to have front wheel drive. Yeah. And then you feel how little acceleration actually comes in such cars from the front wheel drive. Also, like I felt the same in the Ferrari SF90, where in EV mode is just front wheel drive, and you can feel like how early the wheels slip and how limited it is. And you can see that like this is so small because of that, and this is big because it's rear wheel drive for a big family SUV. But this will be just produced in a few hundred units. This will be produced in tens of thousands, and we are just installing a production line to produce it automated way. So I think it's also interesting how technology that we develop for hypercars trickles down to, family car. This will be a family car.
Of course, and I guess, family car, big SUV, and already 5 or 6 years ago, people were commenting on the products that you were making, saying like, this is cool, but I want to see it in a hot hatch in the future.
Yeah.
And I think the next step was probably going to be some nice hot hatch.
Actually, we have some very interesting projects now with some really, let's say, bread and butter car manufacturers that say like, Rimac is cool, I want to make a hot hatch with Rimac's powertrain and like present it also in that way, because people know that if it's Rimac's powertrain, it's going to be probably a cool car.
Yeah, of course.
So there will be hopefully these kind of cars on the market also quite soon that are really affordable. So not just like big limousines and SUVs, but also maybe some hot hatches with that stuff.
Otherwise, we can always swap it in my Honda.
I guess it fits. Yeah. I mean, you can lift it up. It's 82 kilos.
Well, not by myself, not through my back, but like on one side, yes.
Yeah,
it's really not that bad.
It's not that big.
So I think the gearbox alone of a Civic is around 40. So this could be the whole drivetrain on itself.
Exactly, and one of these, so one half, let's say one motor and half of the inverter is in the back of the tourbillon, connected to the 8-speed double clutch gearbox with a combustion engine. So it's interesting what you said when we talked about the architecture of the Chiron. So if you think about the Chiron, it had in the front a differential that didn't do much. Like it's not adding performance, it's just there to distribute torque, and that's about the same size and same weight like this thing, like maybe a little bit smaller and lighter. But now you have this thing that adds like up to 800, 900 horsepower. I mean, it's in the tourbillon, again, the battery is the limit, the powertrain can do a lot more, so it's actually like you are not using the full potential of the e-axle, but maybe, it gives potential for something else when the batteries improve. But this little thing, you replace a passive component, like a differential, with something that gives you torque vectoring, that gives you front wheel drive. You don't have to have the drive shaft going through the... That's the reason why the tourbillon or the Chiron had the gearbox in front of the engine, so that you can have a shaft going from the gearbox to the front differential, but then also a shaft going from the gearbox to the back differential through the engine. So this whole thing makes it a lot simpler.
Yeah.
So we're done in Jankomir. We can go back to campus now.
Let's go. Oh, has Apple CarPlay.
Yeah, of course.
I wasn't there when I was still in the company.
It did a thing or two since you left.
I know. Very cool.
So this car has 39,000 kilometers.
Wow.
For a hypercar, that's really a lot.
How many sets of tires?
A lot. On rear tires especially. But now we are on winter tires, so I don't want to destroy them.
No. It's also not that ideal.
Yeah. But I plan to go to St. Moritz and a few other places in this winter with this car. On, the ice.
Yeah.
So I'll go with the Nevera.
Wow.
From here, from Zagreb.
Are you gonna have studded tires?
That's a good idea. Yeah. I didn't plan to, but probably should.
You heard it here first. You're welcome.
Yeah, I mean, I have rented tires on the car, so
Yeah.
and it's, you know, torque vectoring, 4 motors, so it's like the perfect powertrain for snow and ice. It's
Yeah.
like perfect. Like the control when you hit full throttle, like with a 2,000 horsepower car, even over ice or snow, it's just like perfect. Like there is never slip.
Yeah.
If you don't want it. If you want it, then of course there is.
Yeah, I believe one of the first videos that was done with Nevera and Mergut, one of the like really hyped ones, was actually on snow and ice.
Yeah.
All the donuts, all the, not just 360s, but 720s, and everything
exactly.
beyond.
But let's try what we discussed before. So let's just do front wheel drive.
Yeah.
So 2,000 horsepower Golf. So rear, we put to 0.
2,000 horsepower Civic.
Yeah.
But it has the torque, so it's a 1.9 TDI.
Yeah, with the red DNI,
Yeah.
proper Balkan stuff, you know?
Yes.
That's like the Balkan car. So we have now 100% in the front,
Okay.
0% in the back.
Max Verstappen hates you.
I hate me, because I hate front wheel drive. So I never do this usually, but we can see now. So you'll see when I hit full throttle, like the car won't go anywhere. So 3, 2, 1, full throttle. And you can just feel the traction control.
Yeah.
Controlling.
Struggling.
Yeah, and I can feel it on the steering. So it's really weak with just the front. So the traction is really limited. So this full throttle, you can see 260 Newton meters
Per wheel.
per wheel. I mean, that's on the motor.
Yes.
Then you have the,
loss of traction on the tire, of course.
no, then you have the multiplication of torque through the gearbox. It's 5.7. So you multiply it by 5.7 because that's the gearbox ratio.
Yeah,
And that's
so
the torque
over
you have on the
1,000.
wheel.
Well,
So I think on the wheels with all 4 motors, we have like 15,000 Newton meters on the wheels, because that's what people don't get with electric cars. So it's also the manufacturer's fault. They don't really explain it well. So some manufacturers claim the torque on the motor shaft.
yeah.
Some manufacturers claim on the wheels. And then, you know, you see a big
Difference.
you know, a big article says the new whatever Tesla Roadster has 15,000 Newton meters. Yeah, but it's on the wheels after you multiply it through the gearbox. So one thing is on the motor, another thing is on the wheels. And like a Chiron in first gear has like, I don't know, 17,000 Newton meters or something like that.
That was the first episode of Mandes with Mate.
Yeah, exactly.
Yeah.
exactly.
Oh,
So-
I need to undo the butt heating, it's way too much.
Yeah.
That's
So-
very quick reaction. Good reaction time.
Yeah, we have an okay infotainment system. Could be better, but in the end, you know, I'm like huge fan of Apple CarPlay, and that's also with the Tourbillon. Like there is. So we went for digital detox. So I guess 2 things that people expected with Mate, the electric car guy, and the digital, you know, young guy coming to Bugatti. Like the car will be electric and it'll be like all screens and stuff.
Yeah.
And I went exactly the opposite. You know, the biggest combustion engine on the market, 8.3 liters, V16 naturally aspirated engine, and what we call in the interior digital detox. So the idea is like in normal conditions, you don't have the screen, it's inside, you don't care. If you need a navigation, if you need a map, if you want multimedia, you know, show a little bit more information, the screen comes out, you have Apple CarPlay, that's it.
Yeah.
You know, super simple. And then because we have these beautiful analog instruments, they are very, very beautiful, but a bit hard to read. A lot of information with needles and stuff, and we actually got, and that's interesting when you drive an older car, you realize that you forgot to use analog instruments. Like what used to be very simple to read, like kilometers per hour or whatever on a needle, you are just used to reading a number.
Yes.
So now what we have with that screen is also like super simple performance screens. So like for example, shift indicator, like on a rally car. You know, like it just shows you, you don't have to look at needles, it just shows, you know,
The
like,
number.
But also like green, blue, red, you know, red and then flashing when you need to shift.
Nice.
You know, you have these million choices. Like for example, we discussed about it, the Chiron has auto shift. When you don't shift up, it auto shifts itself.
Like regular Volkswagen Audi Group product.
And I think with that car it kind of makes sense because it has a flat torque curve, so you don't really feel, and you can't hear really because of the turbos. the RPM. So you really have to watch it, and it has this little digital screen there for the RPMs. So I think that was the right decision for the Chiron. And then what people tend to do is like, well, it worked there, so you just do the same. But I hate when the car makes decisions for me.
Yeah.
Like it tells me I'm an idiot, you know, kind of. And I don't think that our customers are. On the opposite, I think that our customers are very smart people that know what they want. And when they are in manual, I don't want it to auto upshift. So that's why we have this visible indication, like, okay, now, you know, the car tells you you should upshift, but it's your decision. If you want to keep it in the rev limiter and, you know, slide it around, you can do that, you know.
What about revving stationary?
Yes.
You can?
Yes.
It doesn't limit you to 4,000 RPM?
No, believe me, I made damn sure that's the case. And you can do it while driving, so you pull the boat handles to you.
Okay.
And you're in neutral while driving, and then while driving you can shift it back into a gear and, you know, just go.
Nice. What was the silliest thing you had to implement in a car of such caliber to get like street homologation?
One story I love is like, people don't realize how everything is connected. So because of the door that's dihedral, and because in the US there is a law that tells you that you have to test unbelted.
Yes.
So you have to crash test without the belt. That's why, because of those two things, you don't have much knee room in the car. And you're like, how does this, like, what does that have to do with each other? So first the door. So when you have a door like this, the dihedral door, it means there is a ceiling here, right? The part of the roof opens, which helps you to get in and out, which is great for ingress and egress. It's much easier to get into this car, for example, than a Chiron. But that means you have a ceiling here. So you have this whole section that has a thickness.
Yeah.
And you can see that inside the door, it's, you know, you have negative space for your head, but you have something sticking a bit out here.
Yeah.
So when you are unbelted, the problem is that a seat is not flat. A seat is at an angle.
Tilted.
So when you are not belted in, what happens is you slide forward and you go up. You go up. And as you go up, the danger is that you hit the head with this, so that you hit this with the head, and then as the body moves forward,
You break your neck.
you break your neck. The neck snaps. So what you need to do is to catch the dummy, the knees of the dummy earlier, so that the body starts rotating towards the
The steering
down.
wheel, yeah, the airbag.
Yeah, towards the airbag, and that you don't hit the head with, that you don't hit this with your head. So that's why in cars with dihedral doors, like the Tourbillon or the Nevera, you have less space here. Just because of this law in the US that you need to test with unbelted
Oh wow.
dummies. So like, and you would never guess so if you get in a Tourbillon and you're like, why does this have less
space than a normal car.
Yeah. And then, you know, no one would connect that it's because of the door and because of a regulation in the US, you know.
Oh, man.
That's just one example. There's 1,000 examples like that.
Yeah. The other thing is like the trunk gets delivered with a separation compartment.
Yes, because otherwise
you might put a baby in there.
No, there is a bizarre test actually. There is a dummy like this.
Yeah.
It's like a, you know, it's like a, I don't know, a 2-year-old, 3-year-old, and that's like the minimum size of a human that if it fits in the trunk, you have to have an emergency release inside of the trunk.
Yeah.
And that's the case with the Nevera, and it's also the case with the Chiron. So the Nevera actually has an emergency release inside. So if someone locks
there,
who
can you lock in there?
It fits, and it's bizarre, like, because we have this glass panel on the back, and there was this test where there was like a child in the trunk closed. so we had to have the emergency release, but in the Chiron we deal with it in a way that it's delivered with the divider. You can't put the human inside.
Yeah, just like certain BMW M models are getting delivered with spoilers and stuff in the trunk.
Oh really?
Yeah, because they're actually not street legal.
Not street legal.
But the customer needs to put them on like that. I think some cars might have it, like some DTM versions or something, but in any case.
Another thing for the Tourbillon, it's quite cool. So we don't have any speakers in the car, right?
How? What?
We excite the surfaces in the interior.
Ah, you mean for the engine?
No, for the music.
There's no music in the tourbillon.
There is very good music. We did for the tourbillon something else. I mean, what is a speaker in the end? It's a magnet with a membrane.
Yep.
And as you vibrate the membrane, it sends waves across the air, right? It moves the air. And what we are doing now, instead of having a dedicated membrane, just the interior panels of the car
Are the speaker. Wow.
So you have exciters to excite the surfaces, small little ones for high and medium tones, and bigger ones to excite the structure of the car, the monocoque. And that saves a lot of weight and space. So for example, we now have cup holders because we don't have speakers anymore. And now in electric mode, you have to have a warning sound for pedestrians at low speeds. So we just want to do, like, there's no fake sounds in the car. We don't fake anything. It's just like to fulfill that pedestrian protection requirement. Yes. So what we do on the outside, we excite the bonnet of the car. There's no speaker. Like this car has a speaker and it's quite big and heavy. Yeah. So in the tourbillon we don't have that. We have just
we have here the big subwoofer. The monocoque actually has space for it.
Exactly, exactly. But in the tourbillon, for the outside, for this warning to the pedestrians, we just excite the surface of the bonnet. Wow. And it becomes a super clear speaker. We actually did that. You can play music on it, and it's crystal clear, great sound of quality of music. Those kind of things are needed for certification. Yeah.
Epic. Wow. Well, let's go have a look at the campus.
Yeah, let's do that.
Right, we are now back at campus, and the small components we saw earlier at Jankomir are already here. Are those prototypes or actually already the first cars or crash type cars? What are we looking here at?
Actually crash cars, but we have 3 phases of development. Just as we have A sample, B sample, C sample, D sample for the components, we have those phases for the car as well. So XP is the first phase, experimental prototype. Yep. They are like 60% developed. It doesn't matter how you build them. We build them in the prototype workshop. It doesn't have interior, fit and finish doesn't matter. It's just to test like suspension, first crash tests, powertrain, to get the feel for the systems. Then the next phase is VP, validation prototype. They're already built in the production line with the right production system. They are like 90-95% done. In those cars, we still change I don't like this button, let's just change this symbol on the button, or this panel is not stiff enough, we need to stiffen it up, stuff like that. But the big stuff is already defined, and these are VPs. And then we have pre-series, that's the next phase, that's 100% done. So here now it's a very special moment, because on the same production line, we are producing the Nevera Rs, the world's most powerful production electric car, and tourbillons at the same time on the same line. So a very special moment in history. Wow. And especially here, this was my vision for the campus. You work on the world's most exciting cars, and you look outside to nature, to the 15th century castle over there. We need to clean stuff up here, and it's not completely done what I wanted, because here needs
We're still missing the sheep, right?
We're missing a sheep, we're missing a lake, a park, gym, sports facilities, restaurants, that's all coming. Step by step. Rome wasn't built in a day. But yeah, I mean, this, seeing it finally here, we have developed this car for the last 5 years. From ground up, completely from scratch, there is not one part from the Nevera or the Chiron or from any other car. And it's really, really special. So many things about it. If you just look here.
The detail of the double wishbone assembly is insane.
Yeah, because this is these organic shapes are only possible by 3D printing.
Yes.
So you asked how can this car be lighted in a Chiron? Well, it's lots of architecture, just smart way of thinking holistically about the car, not individual components, but the whole thing. But then also on a sub-assembly level, like here in this case of the suspension, by doing this, we have reduced the weight compared to Chiron by 45%. Yeah. Just of the suspension components. And we use lots of 3D printing also here for the crash or for the braces in the structure. It's a completely different architecture. When you look at the Bugatti, you sit quite far forward. So your feet are basically within the wheel envelope. So here's the wheel, right? And in every Veyron Chiron, you feel like your left foot on the driver's side is being pushed a little bit in because
Yes.
of the space for the wheel.
Not as bad as a Countach, but still.
Yeah. So here we try to have it more comfortable. You can see this bulging out. That's because of the footwell area. But the interesting thing is it has a very short front overhang, and in that front overhang we had to add 2 electric motors, 2 gearboxes, 2 inverters, and the cooling system for the battery, for the engine, for the inverters, for the motors. And we did all of that without making the car, just making it 39 millimeters longer. And actually we have a bigger boot.
Yeah. Wow.
It doesn't look like that, but it's also totally different than a Chiron. So in a Chiron you have like, the radiator is laying flat and it's like from side to side.
Yeah.
And the air comes into the radiator and goes under the car. That's bad for 2 reasons. One is when air goes down, car goes up, so it's lift. Second one is you don't want this dirty air to go under the car and disturb the rest of the flow. So what we did here in the Tourbillon is different. So we now don't have the trunk on top of the radiator. We have the trunk deep but narrow, but volume-wise it's bigger. And the cooling systems for the battery and for the electric powertrain are going left and right from the trunk and go upwards through the bonnet and over the car. So the airflow goes out of the bonnet and over the car. So we have different temperature levels in the cooling systems. People think like electric powertrains are easier to cool. They are a lot more efficient and radiate less heat as waste energy, but the maximum temperatures are a lot lower. So you have less delta temperature between the environment and the maximum temperature of the systems. So an engine, like the oil, can go to 115, 120, and you know, even if it's 40 outside, you can still cool it. A battery shouldn't go above 65. So if it's 35, 40 degrees outside, you don't have enough delta temperature between the air and the maximum temperature of the component. So you also need to use refrigerant coolant, so the air conditioning of the car that cools the cabin, to when it's very hot outside, to also cool the components. So we have low temperature cooling circuit, that's the battery, maximum 65 temperature, it's 65 degrees Celsius. Then we have the medium temperature circuit, which is for the inverter and the motor and the DC-DC converter and stuff like that. That's like maximum of 80 or 75, 80 degrees maximum of coolant temperature. And then we have the high temperature coolant, which is for the engine. So engine water, but also in the back, engine oil. So cooling is very, very important in this car, especially as we move towards the back. There is a lot of stuff going on here in the back with the V16, huge engine.
Of course.
But then, if you remember, the gearbox used to be in front of the engine in the Chiron.
Chiron, yes.
So you had all the back, just space for the mufflers and for the exhaust system. Now in the back you have the gearbox, 8-speed double clutch.
Yeah.
You have the electric motor, and very critically here the inverter, which drives the motor, which is right above the exhaust.
Wow.
And this gets to 900 degrees.
Yeah.
So you are cooking the inverter. So getting the heat out of here is the biggest challenge of this car.
Wow.
And we already had tests in Dubai, 50 degrees Celsius and stuff like that. So it's good, but a lot of engineering, simulations, wind tunnel testing went into making sure that this works. And that's why you see lots of heat shielding. And you know what we discussed, I want to make sure that you can rev the car while being stationary.
Yes.
Like, it's a silly thing, but actually these things determine if you can do that or not. That's what makes it possible or not.
Of course.
And then also this is super interesting. So
that's a honeycomb structure in there.
Yes, this is 3D printed. So the suspension is 3D printed, this is 3D printed. And this on its own doesn't mean anything.
Yeah.
But this as a whole is a game changer.
Okay.
So in a Chiron or in a Nevera, you would have a big metal beam here, which is the crash structure.
Yeah.
And that would limit the back of the car. If you have a tourbillon fully assembled, maybe I can show you on one later. It's let's go to this one. This is more assembled. That crash structure would close the back. So in the Chiron, it's pretty closed, and in Nevera as well. In a tourbillon, it's very open. The wheel is almost completely exposed.
Which is good for aero, no drag.
Exactly, also to get the air out, the hot air, it's pretty open in the back. But so many things play together here to make this car what it is. So just give you an example. You want to generate downforce, not drag. So wings generate downforce, but they come with a lot of drag penalty. You have airflow under the car anyways, so you can use that airflow to generate downforce, like ground effect. And that comes with less drag penalty. So what we wanted to do with the tourbillon is to maximize the downforce from underneath the car. The way we did that is narrower engine. So the W16 is very short, but it's very wide. V16 is longer, but much more narrow. And then we have the car, the engine and the gearbox at an angle. It's not straight in the car, it's at an angle. And that makes space for the Venturi channels, which start in the middle of the car. So basically, this is where you sit, this is the battery pack. And the Venturi tunnels start there. And they go left to right from the engine and kick up at an 11 degree. So 11 degrees is about, or 15 is maybe the maximum that you can do, because otherwise the air separates. It doesn't stick anymore to the surface. So
you have also teardrop shaped.
Exactly, that's wing-shaped suspension.
Yes.
And here you can see, like when the suspension is not in the airflow, the ideal suspension arm geometry is something like the upper wishbone. So you can see it's like, you know,
open,
it's like, it looks like a bone.
Yeah.
But this one is in the airflow, so it's shaped by the air. And this takes a lot of load from the, you know, when you accelerate with the car, when you brake, when you corner, or when you hit a bump. So it's taking a lot of load. So this wouldn't be possible if it wasn't 3D printed, because we have now lots of little structures similar to the honeycomb you saw on the crest structure. This is, it has lots of these structures inside, which you cannot do with a traditional manufacturing methodology. And then to enable such a long diffuser, because you are limited by the maximum angle of 11 degrees, you have to, if you want to have a big diffuser, you have to start far. And now if you had the crest structure here, you wouldn't be able to start this tall, you would start here. So if you start from here and your maximum angle is 11 degrees, you end up where most cars start, behind the suspension. So all of this works together. 3D printed crest structure, which is part of the diffuser, 3D printed suspension arm, which is shaped in an aerodynamic form, a narrow engine tilted with two big Venturi channels. So this can't work if you look at components individually. Like there needs to be someone who looks holistically at it and has these ideas at the beginning. So that's why
you had to do it everything from scratch.
Why you have to do everything from scratch? And I like to say that the tourbillon is a car that's like from a single pen, like it was drawn, you know, the concept was like coming from one sketch, you know, because all of these things cannot work individually, so you have to know them at the beginning of the project. And we really nailed it with this car, and you will hear what comes out of here. Totally incredible.
Nice, I cannot wait.
Ogeszki. Here we can see some other trickery to not make the car any longer. So you see how well integrated the battery is in the chassis, in the monocoque. So the tunnel and then the back here. And you see this shape. It's exactly the shape, so the shape of the backrest of the seat is fitting exactly to the shape of the battery modules in the back. And the seat is not moving forward or backward. It moves up and down and you can change the angle, but the pedals are moving electrically. So with that we reduce the length again a little bit. So all of these things together make sure that the car is not any bigger. And you can see also inside here all of these mechanical pieces, like
all the tumblers and
so all the
nice
analog way of running the car. And the doors open electrically. So one thing I learned in Nevera is, especially ladies have a problem with dihedral doors, because actually it's usually you have a gas strut, and the gas in it is expanding or contracting depending on the temperature. So when it's hot, it's very easy to open a door and like shoots up, and it's harder to close it. When it's cold, it's much harder to push the door up, like you just saw. So we decided here it's electrically actuated, so you can open the door with the key, so it electrically opens, or with buttons in the interior.
Do you add extra protective layer in the door handles? Because one of the most PPF structures is for the nails of the ladies.
No, it's just a button on the outside, but I thought you mean like manual release. In case that fails, there's a manual release. But what I wanted to show you is this cool period in the history where here this is a Nevera R, and right next to a 4-motor electric hypercar is a V16.
Oh, wow. So the intake manifold is painted in a nice color. I guess that's something to be chosen by the client or not?
Very difficult, because this is actually the first one where we test this.
Okay.
It's because, what is the thing? Now, if you put an engine in a car,
yeah,
and it has a failure, for whatever reason, there is a noise, you need to get it out, and this plenum is mated to that engine. It's hot tested like this.
Okay.
So if you have now a special plenum for that customer,
with
for that
different
engine,
colors and everything, yeah,
and you need to replace the engine, you have a problem. Like the customer wait months on their car. So we try to not make this customizable, because it could disturb the production, but maybe in some very, very special cases we'll do it. So this is just to test it. So here you see the engine. So 1,000 horsepower combustion engine, V16, 9,500 RPM.
it's really compact, I must say, for its size, for the, like when you compare it again to the Chiron engine, that's like a car on its own.
It's 200 kilos lighter than a Chiron engine. So
Yeah.
this is 250 kilos, the Chiron engine is 450 kilos. Just the engine, plus all the piping, intercoolers and this kind of stuff.
Yeah.
And then 8-speed double clutch gearbox with no reverse, because the
You're
reverse
doing
is
through the electric powertrain?
electrically, yes. The electric motor, so the one we make in Jankomir, so this is made there, with the inverter separately. So this thing can provide like 500 horsepower. And that's the interesting thing about the electric motors, if you look at it. This compared to the V16. This is also the starter motor, so you start the engine with that. There is no 12-volt starter motor.
Okay, all right.
It's also the generator. There's no 12-volt generator. It's also generating 800 volts, feeding the battery, and then the battery through a DC-DC converter charges a 12-volt battery.
Yeah.
So there is no belts, there is no air conditioning, there is no fuel or no pumps like water pump or any kind of hydraulic oil pump for other systems. It's all electrically done, also reducing weight. So for example, the spoilers in the back, in the Chiron or even in the Nevera move hydraulically.
Okay.
In the Tourbillon, it's already electrically.
Yeah.
Yeah.
Oh, nice.
So we try to sub-assemble the components as much as possible outside, so separately. So here, now this is just the powertrain. Now comes the frame around, the suspension, everything is assembled like that and then gets married to the frame of the car.
Nice.
And we do this, so the full XPs, VPs are built in Zagreb here in the campus. But then for the series production, some parts will be done here, but the final assembly is done in Molsheim in the historic site.
Yeah. To keep the tradition alive,
Of course, it's 116 years, that location, and you know we want to keep that, of course. This is the proto workshop, so here they keep the cars updated, service them, do whatever they need to fix things. So you see these are XPs.
Yeah, experimental.
This is VP. And most of these cars that are not painted, they are just being crashed at some point.
Yeah.
So XPs you build actually like this. So here in a garage type of thing. So these camouflage cars are XPs, they are now here to get upgraded to VP status. So these cars were like in Sweden, you know, in frozen lakes, in Dubai at 50 degrees.
Yeah, you saw the, what's it called, the proto spy shots of these cars,
Yeah,
actually.
exactly. But you see, there's lots of cars. We made 8 XPs, and I think there will be 15 VPs,
Yeah.
and then pre-production cars. So lots of cars that you have to build. And then you rebuild them over and over, crash testing, upgrading the technical bits. Okay, now we come to my
All right.
man cave.
Now we come to the coolest part.
Yeah.
I believe the license plate is a lie. He hasn't done a sub 7 yet.
He did, I think.
Did he?
I think so.
Did he? Finally?
I think he did, yeah.
Okay. Well, Goran, let us know in the comments below.
Actually, the favorite car.
E39?
I love to drive this, man. This is my, like, ideally, the Nevera, Chiron, and this. Really love this car. And I just bought, like, a beautiful car. I really wanted a Phaeton.
Yeah.
And I found the best Phaeton on the market, the W12, with, like, the extended wheelbase and the back seats, like, separate seats. And beautiful example with the crazy paint. And unfortunately, I never sat in the car. It was outside of the campus, and one of our colleagues had a little accident and totaled my Phaeton and my R32.
Not the R32.
And the R32 totaled. So I lost 2 cars. But I'm most sorry about the Phaeton because
You never sat in it.
I never sat in it, and it was such a nice car.
You know, I think there's so much that connects us, and I feel now a deep connection because I built a Mark IV TDI Golf. Remember that I had?
Yeah.
I built it to a race car, had it built, and I never sat in it, and the car got flooded by like emergency flood.
Yeah, I remember that. Yes.
And now 5 years later, I'm actually rebuilding it.
The same car?
Yeah, full carbon fiber, wide body, everything. So like maybe you can actually now rebuild those two.
Yeah, maybe I will. Yeah.
Or just buy another.
Let's
one.
see. Yeah.
Maybe in 5 years.
Yeah. So here are a few cool things. I mean, this is not all my cars. Like this is a Mistral prototype. We just sometimes leave stuff here.
Just random, yeah.
Yeah. This was I think the first Mistral prototype, or let's say pre-series car. Pininfarina Battista, this is my car. So this is built on a Nevera. So I try to have each of the cars that have our tech. It's an expensive hobby.
Yeah.
SLR, beautiful car, but
horrible to drive.
Horrible to drive, exactly. Carrera GT, of course. Which collection is full without that?
Yeah. Is it fixed yet? The clutch had issues.
Yeah. Well,
we already had 5 more clutches.
Yeah, exactly. And then the E30, you know, that's the thing now where I will shatter dreams. Because everyone thinks like these old cars, they're so amazing. This was like the peak of automotive. They're so like on such a different level than cars today, but I have to disappoint. Like when I drive that car, I'm so disappointed. It looks so beautiful. I love it for what it is, but it's so boring to drive. It's so slow. The steering is like, you know, when you turn it like this, nothing really happens. You know, everything rattles in the car. The gearbox is imprecise. It's a lot of old plastic. So I think this car would be amazing if you resto mod it to a V10, you know, and have a better suspension, better brakes. Then it would be cool. And that's what I actually want to do. But as it is now, it's just super boring. Like anyone who is used to any kind of normal car today, like a Golf GTI or something like that, would be disappointed by the performance of this one.
Well, resto modding the E30 by Rimac was one of the projects we were looking into feasibility 6 years ago for 10-year anniversary.
Yeah,
already.
I would love to do this actually.
Come on.
So it's on my list. It's on my list, yeah. Of course, CSL, very cool car, but also a little bit like that. I mean, it's an icon. It's amazing to drive, but it's also quite slow, and it has the SMG gearbox, which is a bit slow. But yeah, I love this car. It's for me, it's the perfect ergonomy. Like when you sit in that car, it just feels.
Yeah. I love it as well. Oh, yeah. What's with this?
I made this as a present for a little girl that just got it a couple of days ago of friend's daughter. So she told me she wants a pink car, and she got a pink car.
She got a pink Bugatti. Nice.
Yeah. So nice present, I think.
Yeah, very cool. Epic.
Yeah. So this is my collection.
Is it someone else's CSL?
No, I have one high mileage one. I mean, high mileage. It's like, I don't know, 40,000 kilometers.
Yeah.
That I use, and this is like super low mileage.
Okay.
So I don't know how much this one has. Like, I never used it.
Wow.
Yeah.
Nice. For me, E46 is also like probably the best M3.
Yes. The most beautiful, for me, this is peak BMW.
Yes, the design-wise, when it comes to the engineering of the engine, of course, the S54, but also the styling, it's so timeless.
Yeah, it's a great car.
Oh, that's the low mileage one.
Pity, no, this is the high mileage one.
But it says 22,000.
No, sorry, you're right. This is the low mileage one. Yes.
Yeah.
That's the low mileage one.
Yeah, 22,651 kilometers.
Yeah.
Wow. And someone already ate on the driver's seat.
Yeah.
I see breadcrumbs.
I never drove it.
No.
I wonder sometimes, why do I have these cars? Like, I
do you even get time to drive them?
No, not really.
That's why you daily the E39.
Yeah.
Yeah.
Yeah. But I love detailing that car. It's really, I'm thinking about buying another one just because I'm really using this one, and I damaged it already in a few places. So. But it's cool.
Nice.
So we are already tearing down walls that we just built, building new ones, moving departments, playing Tetris, because we run out of space in this huge facility.
Insane. So how many phases did the campus have again? Because you have like the phase one that is now kind of finished with this big building.
That's
and
phase
then,
one, yeah.
Yeah, and then you're gonna have many, many more buildings. As many as we can.
Endless.
Yeah.
Who knows, man?
the lunch break now, or is it just?
No, this is this production line for BMW, which
Okay.
we are now installing, and the series production starts in April.
Okay.
So they are now installing the line.
Yeah.
This is part of a huge production line that we have for a big car company, where we have developed the battery and now we'll mass produce it for multiple models.
Can we name the company?
I think we can say it's for BMW, but I can't say which model exactly.
You know what's funny? So you're developing the next gen battery technology for BMW, or next gen powertrain for BMW.
Yeah.
And the reason why all of this is possible and happened is because the old drivetrain
In an E30.
broke. Yeah, one day.
We have a great collaboration with them. They are really great customers, and we are very connected. And I think one of the things they loved when they came here the first time, it was such a, for me, a closed loop, like closing the circle. Like I was always so crazy about BMW, and I told them like, my dream was to work for BMW. Anything, swipe the floors, be a low-level engineer, anything. I just wanted to work for BMW. That was like my big dream. I was so crazy about that brand. And then, now we work with them on their future cars. I know what's coming, we are part of it.
Will it have a drift mode?
That's up to them. I guess a BMW should, right?
Yeah.
And then, they come here as the whole management board and they look at what we do and they're like blown away, like, wow, we can't believe what you guys have built. And like they that live this every day, see many other factories and other car companies, they love what we do. So for me, that's like make me proud. If I knew that 15, 20 years ago that would be the case, I wouldn't have believed it. So yeah, this is a big, huge production line. This production line is actually more expensive than the whole campus. And we are setting up the production line, so the series production starts next year. So the guys are still setting this up, and then this will run like pretty much 24/7, fully automated. It's Industry 4.0, so you don't have like a normal production line. You have these robots that go from station to station and know where they need to go next for the battery to go to the next step in the process. And the production, so the main part that we make is the module, the battery module. That's 97% automated. So almost a fully automated line, like hundreds of robots working together as one, and it's crazy when you see that working together. So yeah, from a few years ago we were just hand making batteries for Koenigsegg and for Aston Martin and stuff like that, to now high volume production. It's a huge step.
That was also the main goal.
Yeah, that was the goal. And this business, so not just BMW but everything we do, brings us from, I don't know, like a few years ago it was maybe 50 million euros revenue, now to in a couple of years, it'll be €1 billion just by selling batteries per year. So, big business.
Big business.
But also becoming a big part of Croatia's GDP, and Croatia's economy, because Croatia had not really that scale of automotive industry before.
They didn't have any.
We had to build it up.
Before you had Yugo and Yugoslavia, but not anymore.
Yeah, that was not Croatia.
Times. Yeah, exactly.
Yeah. So, but it's also cool in this same facility. You have like hand making carbon fiber and painting. It's almost like artwork, craftsmanship, like really manual labor, and then assembling Neveras and Bugattis. And then in the same facility you have highly automated, robotized Industry 4.0, and like that's super for the kids to go around and see. Like there's I don't know any other factory like this where you have like low volume, ultra performance and luxury on one side, and then super automated high tech on the other side.
How many people do you have by now employed?
2,500.
2,500.
Yeah.
Nice. Do you
From
know
55 nationalities.
Wow.
We bring together a lot of young people, but also people with experience from all around the world.
Yeah, that's nice. Because I remember back then when I was still part of it, was mostly a very young company, and that was actually very, very cool.
Yeah, I mean, to be honest, at that time we couldn't afford to hire people from Germany, from France, from Italy, from UK. We couldn't afford. So most of us were first job students.
Yes.
And we built a car, and it's a good, really good car. So we just didn't know. It's us in the room. That's the amount of money we have, and we are constantly running out of it. And we have to do it. There's no one else. Like, even if someone says, we don't know this, and we need to now go to a supplier, or like, you can't. We don't have the money. We just have to do it.
Yeah.
And I think that's our spirit. Like, nothing is impossible. Like, if you look at this, like, this was a field a few years ago, and like, to think that you would here in Croatia do this, or Bugattis, or the fastest electric cars in the world, like, absolutely insane if someone said it 15 years ago. So that's our motto, like, nothing is impossible, we can do it.
Yeah, and going back to the people, not only you hire now the more experienced people from other companies, people who started with Rimac, actually some of them have left to the other companies in the other side of the world.
Or start their own businesses.
Exactly.
And many of them I support. Like I used to be like, years ago, I used to be every time offended someone left the company.
Yeah.
And I changed that completely. I don't like, I'm happy for the people to do something else. Many of them eventually come back. When they start their business, I'm happy for them. I help them however I can to connect them with people. Sometimes I invest. So, you know, I think it's fair game, you know, learn as much as you can here, go do something else. Maybe you come back, maybe you won't. You know, it's all fair game. I mean, like you know.
Can we do aero together? Like, do like some Nürburgring lap record car?
Well, the limitation is time. The limitation is always time, so I try to simplify my life. You know, I also had a bike company called Grape.
Yeah, I have still one.
Yeah, you have. Yeah, exactly. So that was bought by Porsche. So, you know, I also have, we don't talk about this today, but we have also a robotaxi company, Vern, where we develop robotaxis. So life is pretty complicated doing what we are doing, so I try to stay out of too much stuff, but happy to do something together maybe.
Stay tuned.
Yeah.
Yeah, these are like concepts. You can swipe through them.
So you'll do the whole new body?
Yeah.
Wow.
We went into the body, into the rest of the body.
Yeah.
So, E30.
Yes. This is the big production line for the BMW modules, like huge. Like this thing costs 130 million.
Wow. Oh, speaking of silly cars, I bought a Honda AMG. Back in the 90s, AMG made some Honda Civics for South African market.
Never heard of that.
So I'm gonna go pick it up and I'm gonna take it to HWA and ask like, what?
Do they even know about it?
Non-Honda or AMG want to admit that they built one.
Really?
Yeah, yeah.
That's it?
Yeah, so Honda, AMG badge.
No. This looked like someone, you know, in a village, like
exactly.
Just put it on.
Yeah, it actually comes with like the,
Where did you buy it?
South Africa.
Oh, wow.
So I need to go pick it up.
Okay.
Kevlar?
No, it's carbon. It's just a cover. This is so it's pre-preg carbon, so it's already pre-impregnated. And what in the end turns out to be one part, like here for example the laminated door, it's actually 550 carbon fiber plies for one door. So this is a ply. It can be a small piece like this, it can be a big one. Each one has its numbering, and there's a sequence and how they need to apply it, and exactly the right sequence and exactly the right angle, exactly the right material, because it's also different materials. It's not always the same material. And it's then multiple parts. So this is one part of the tourbillon door. So you can recognize this is like the inlay. So the tourbillon has also the option of sky roof.
Okay.
So you have here, it can be a carbon fiber panel or glass, right? So they laminate it here, and you can see it's a very complex tool, which is also carbon fiber, but also aluminum, because you have to be able to take it apart after it's cured. Otherwise you would destroy the part or the tool getting it out. And then you have to bond multiple panels together to get the door. So it's precision is very important, because it has to be everything in a tenth of a millimeter. So after they laminate it here, which can take days for a complicated part, it's vacuumed back in these red bags. So you take the air out of the bag so that you see now carbon is not sticking here.
Yeah, that's going to be vacuumed.
When you vacuum it, you are making sure it's sticking everywhere to the mold. And then it goes into the big ovens, into the autoclaves, where it's curing. And then the part, like this soft carbon, the resin gets hard. And then from a textile-like thing, it gets harder than steel and lighter than steel.
Does the tourbillon have any like world record features when it comes to the chassis? Because I remember Nevera was, maybe still is, the monocoque with like the biggest piece and also the highest stiffness of the structural rigidity. So
with Nevera, we completely overdid it. So it's from the front crest structure to the rear crest structure, it's one piece.
Yeah.
So the front suspension, the rear suspension is on the same piece.
Yeah.
And then the battery is a big structural part. So super complicated structure. Tourbillon, for two reasons we decided to do it differently. First of all, it's not necessary, but second, also because you have the big engine, it needs to be a separate piece. You can't put the engine in a one-piece monocoque. So with the tourbillon, you have a front aluminum subframe, the monocoque, and the rear aluminum and carbon subframe that bolts on. So we learned a lot from the Nevera, and let's say we were more reasonable with the Tourbillon in terms of not overdoing it and just let the engineers go wild, but also think about production and think about, in the end, also complexity and cost. Lots of these huge autoclaves.
I remember last year they were just
Two.
no, they were just standing. They were not even
yeah.
like sunken in. And just two, yes, and now you have all of them.
But maybe interesting just to explain how this works. So you design a part in CAD,
Yes.
right? And it's hundreds of iterations just in a computer, because the designers do something, then the engineers say it's not feasible, packaging, whatever. Then you do CFD simulations for aerodynamics, you do crash simulations, you do lots of like checks for compliance with homologation requirements. For example, the view angles, it's prescribed how the view angle from the driver's seat needs to be and so on. So lots of loops there. And then when you have the finished part, the first iteration, you make a tool. The way you make a tool is usually you make a plug. So this is a positive made out of a material called Necoron. It's like a wood plastic type of thing. Then you make, out of that, you make a carbon fiber tool, a negative, and then you laminate the part. So this is a super simple part where you don't have any undercuts, no negative angles, so you can just have one piece tool, you get it out and that's it. But for anything more complex, which all of the parts are, you need a tool that can be disassembled, because now imagine if you laminate this mirror in this tool and you want to get it out, you can't, because you have these undercuts. So you have to be able to disassemble the tool. So sometimes when it's a simple part, you can make a direct aluminum tool on the CNC machine, but usually we make a plug and then we make a carbon tool, also because of the expansion coefficient, because when it expands in the oven, in the autoclave, carbon and carbon expands the same way, carbon and aluminum a little bit differently. So the same machines here make the tooling. So this is a block out of which we'll make a tool, but we also cut the parts here, so when they get out of the autoclave, they don't have defined edges, they are sharp edges, they maybe need some holes for mounting points. And then you have these fixtures to cut them, because if you just put this structure here, this is the inner door panel of the tourbillon. If you just put it on a table, it will deform, because it's thin, right? Even by 2 millimeters, it's already wrong. So you have this fixture that holds it in shape, but you don't have the mounting points yet. So you have a suction system, so it sucks it down with vacuum. So there is a seal that sucks it and then gives it a shape. So it holds it in the right shape, and then the CNC machine, a 5-axis CNC machine, machines it. You see now it's adding holes.
The holes for the,
cutting the edges. So, and this is just one piece of the door.
Wow.
So then, you know, you have multiple pieces of the door that need to be bonded in a bonding jig very precisely so that on the car it fits. So many steps just to make a door. And you have to do that for every part, for wing, for the monocoque, for bonnet.
Insane.
That's why carbon fiber is expensive. It's not just the material itself, it's just the whole process.
Of course. Because one thing is making it light, but it needs to have structural rigidity, needs to be there in 10 years, or even let alone in 6 months. Sometimes you get like low volume manufacturer supercars, collector's items, and then there's these big panel gaps.
Exactly.
And you cannot afford that.
Precision is very expensive, very important. That's the big thing. But also you can't have any carbon fiber weave that's optically like it has to be
spot on,
because otherwise we can't use it on the car.
Do you offer the option of naked carbon fiber?
Yeah, of course. For Tourbillon and Nevera, yes.
Yeah. How many customers actually go for that? Because you barely see them.
You know, Bugatti is two colored usually.
Yeah.
So it can be that half of it is visible carbon, half of it is not. And I would say like 40%.
Okay.
And it's usually the most expensive option, except individualization.
Yeah. Nevera
Rs. This is body alignment. So this is a Tourbillon, this is Nevera. So here all the parts of the carbon come together to align it on that chassis. So you do all the alignment, all the fit and finish before it goes to painting. So then later that body panel comes to that car after painting. And you can see here. So this crash structure, how it is limiting you. So you see how can we now have a diffuser here? Like in the Tourbillon, the diffuser would go up until here.
Yes.
And in Nevera, you were limited. There's no exhaust.
Yeah.
But you see the diffuser goes under the suspension.
Yes.
So the suspension is inside. It doesn't have to be aerodynamically shaped. And how big of a difference that is compared to the Tourbillon. And the reason why the Tourbillon can have such a diffuser is because it can start here, not here. And then you start the 11-degree angle from here, and then it cuts basically through the car.
Yeah.
So how much change, how much advantage just this part gives when you change it. Yeah, so these are the bonding jigs where the pieces come together. So you mount the different pieces, you add the glue, that's why it's in a chamber so it doesn't smell outside, and you bring it together very, very precisely, down to the 10th of the millimeter, so that you know when it's bonded that it's exactly the right shape that it needs to be.
And that's why there's also much more light in here, so you can see all the imperfections.
Yeah, exactly. Like this is a bonding jig, I think, for the door again, for the Tourbillon.
Wow.
So see, you have these suction cups. So this is a sealing, right? This is a hole where then you suck the air out, because how do you hold the parts precisely in place? So you just shape it in the shape of the surface, and then it's being sucked down, and you then know it's in the right shape. Even if it's a bonnet that maybe slightly deforms, when you hold it here, it's then in the right shape, and then when you add the other parts, the structure, then it's the right precision. Be careful. So this is our painting facility, and this is a really critical part of the production of a car, because this is where you can have thousands of issues. So this is like a Mistral, so the carbon fiber monocoque of a Mistral. So we paint here currently Mistrals and Neveras and Tourbillons. And we have 65 people working in 2 shifts, and it's 900 hours to paint. So we had to start an academy to educate painters, because in Croatia, again, there is not enough painters available. So this is a lot of hand work. It's 800 hours to paint one car on average.
Wow.
And now we paint Tourbillons. This is a Mistral, Bugatti Mistral, and Neveras, so the structure and the body panels. And what I love here was when I come to stroll around, and then I look at all the markings the guys are doing in the quality control, because you really want to avoid shipping a part to the assembly if
That's not perfect.
Yeah, because then it comes back. And it's easy if it's a Nevera, it's right here.
Yeah.
If it's a Mistral, it goes to Molsheim. And then you transport it there, you transport it back. Again, chances for issues. And then I look around here and I'm like, every time...
What do you mean?
Well, exactly. But that's good, because the guys here have very, very high standards.
Wow.
So that never something leaves which shouldn't leave,
Crazy.
And the customization currently, on average, is 500,000 euro per car. So the options on top of the car, it's usually some special painting, or like you see here, visible carbon. That's a quite expensive option. So we want to do more and more individualization to make the car special for that customer. Something that means a lot to them, because then the car becomes more theirs. And we do a lot of that, and a lot of that is happening here in the paint shop. And that's the cool thing about this facility. You have here, this artisan handcrafted work of the highest quality paint possible, but then also automated high volume production.
Yeah, wow. Where the high skill and the human touch and the automation and AI come together.
Yeah.
Some things are irreplaceable.
I love walking through this facility and then randomly.
Yeah, randomly there's a
hypercar half assembled standing.
Can't park there, mate.
Yeah. So this empty space we just freed up and built walls and so on. There's coming a production line for another car company.
Nice. Mate, thank you so much for your time. You're a busy man. You have to run off.
Yes.
But you showed us so much things. I was here just to see the campus, but I got to see pretty much the full behind the scenes like you always do. And that's what I love about the company from day one, the transparency. Because you say like, hey, if you guys can replicate it, good luck. We're already working on the next thing.
Yeah.
We saved the best for the last because now the guys are back from the lunch break. So maybe we can fire up the XP8 of the Tourbillon.
Yes,
and
to hear the V16.
Final words of advice to the future entrepreneurs, techpreneurs, and people who want to get into cars from you.
Are you really sure you want to do it?
Yes, from me too.
Yeah. So, can we start the engine?
She sounds angry. I love the diffuser. A little small personal bonus for you guys as we are leaving Rimac's campus. We're doing things a bit backwards here because we're standing in front of the campus. And we have here this Nevera, or actually back then it was called C2 prototype, the VPR 14, the pre-production series number 14. Back in 2020, when I was still working for Rimac, this was one of the cars we had lots of action with. Actually, 2 weeks after I joined the company, Mergut, the driver, Miroslav, he took me by the sleeves and said, "You're getting in the car right now because I have instructions from Mate for you to drive it." I'm like, what? And then Mate said, like, you need to work with this car. You need to know what this car is capable of, because how else are you able to talk about this car if you don't know what it is? So this was one of the earlier videos that I shot driving back in Navac in Serbia, with this car in a very early pre-production stage. And it's so cool to see it still being here in exactly the same form. And the company behind it grew massively, and the cars that are coming now off production line are completely different. And also I think myself have changed as well, but it's like such a nostalgic moment that I just wanted to include to show to you. We can also see like all the different details that are of course changed completely on the final production. So the lights were different. On the back we have an active diffuser with the very funny stickers on it. And when you open and close the doors, that doesn't sound very production-like. Actually, when we posted the video, it was so funny. Some people were commenting, "Why would you pay 2 million euros for a car that has no dashboard and it sounds worse than the car from the 80s?" It's a prototype. That's actually, again, what I said to Mate. Thank you for showing you, for being transparent, because showing these earlier prototypes back then, or showing now the production line, is something that is pretty much unheard of even still today. Many car manufacturers want to be very secretive about things, about how things are done, because it may create a wrong assumption. But on the other hand, it shows the full process behind it, and it also inspires thousands, hundreds and thousands of others. And aside from the very cool products that Rimac Automobili or Bugatti or Rimac Technology are making, I think it's extremely cool that they inspire countless of others and offer them the opportunity to shape their dreams at this amazing company. And for that I also want to say thank you to Mate, Marta, and many team members that are still working here today to shape me and allow me to do what I'm doing today. So I'm not gonna cry. No, you're not gonna get that shot from me.